So to set the problem up, the first thing we're going to look at is where do I put the triangle? Well, I know where 180 is, and I know where 270 is, right? There's 180, there's 270. So we put our triangle in between. And so we go ahead, since we have the sign, that's going to be negative 4 over 7 because the 7 is my hypotenuse. That's always positive. So the opposite side, and it's also in the third quadrant, so I already know that the two legs of the triangle, right here and here, are going to both be negative. That's a guaranteed automatic. If I'm in the first quadrant, they're both positive. If it's the second quadrant, the horizontal, or the x is negative, the y is positive, because I'm above the x-axis. Fourth quadrant, the x is positive, the y is negative. Go through that. I do that because I can take this little triangle and I can find the cosine by doing adjacent over hypotenuse, which is going to be negative square root of 33 divided by 7. Does that make sense? I want you to leave it as the square root of 33. Instructions would be like, be exact, meaning no decimals. Not to mention it makes this a little bit easier to work with. Okay, and so let's plug this into my problem and talk about one other thing. How did we come to the conclusion that up here we have plus or minus, but now we have just a negative sign? How can we judge that the result is going to be negative just from what's given to me?
Is it inside sign?
Mm-mm. If I know that I'm using cosine, right? It's cosine of this angle. Where's theta over 2 going to end up? Is it the first quadrant, or the second quadrant, or the third quadrant? Well, if I take these two parts, if I cut theta in half, then I can do the same thing to 180 and 270. If I do that, it means, if I really think about it, 180 over 2 is what?
90.
So that would be 90. What's 270 divided by 2?
135.
It's 135. So where would I be if that's where theta over 2 is? Clearly in the second quadrant. I'll tell you right now, if you get a full angle theta that's in the third or fourth quadrants, you're going to end up in the second quadrant. If you get an angle theta that's in the first or second quadrants, you will end up in the first quadrant. Guaranteed.
So you always end up in the first or second.
Right? Because take your maximum angle, 360. Cut that in half, where are you? You're back to 180. So you can't get past 180 if you're judging with theta, unless the angle is way past 360. Right? But we wouldn't do that. Anyway, let's go back to the problem. So now we're here. We have this situation. What I'm going to do is I'm just going to find a common denominator, combine those, and simplify that first. So 7 over 7, that's just 1. Over 2, bring that down. I'm going to multiply by 1/2. Right, I brought these together. I went ahead and said 7 minus the square root of 33 over 7. I'm going to take this 2 at the bottom. I'm going to multiply by the reciprocal. Since we have 2 in the denominator, we'll flip it over. We'll multiply by 1/2. And I'm pretty much done. So the full answer without having to convert anything to a decimal would be negative square root of 7 minus the square root of 33 over 14. And yes, it's fine to have a square root in a square root. I don't want you to go any further than that.
What if you do?
What do you mean?
What if
You can go further than this.
so weird. Yeah, the only thing that throws me is how you get if the whole thing's negative.
Okay, I didn't actually finish that. So if you go back and you look at, we know that the final angle, theta over 2, is going to end up in the second quadrant, right? So if theta over 2 is in the second quadrant, and I'm trying to find the cosine. So if we're looking for the cosine of theta, if the angle is in the second quadrant, I'm looking to find cosine. Is cosine positive or negative in the second quadrant? It's negative. Because sine is positive in the second quadrant. Everything else is negative. Okay? All right, so I'm going to give you a few more minutes. I want you to look at this one. It's solving, it's just basically solving the equation. So sine 2 theta, or 2x, equals cosine of x. Solve that. I'm not going to give you a whole lot of time, but take maybe 5 minutes or less and do that problem. Okay, first order of business when you're given a problem to solve, meaning I'm not trying to verify because this is not true all the time. This is only true a very short, small portion of the time. I need to figure out the exact angle measurements that this really does happen for. If this was an identity, then every angle would make this true all the time, and I would have said prove the identity, but this says solve. Listen. And so what we're going to do, the first thing you should see is you've got a sine of 2 theta. You've got to get rid of that. You can see on the screen, we went ahead and we replaced that with the formula for sine of 2 theta. 2 sine theta cosine theta equals cosine of theta. The next part I asked you to do when we went over this was to get everything on one side, factor out what was common, and set those parts equal to 0. So you can see that here. So we take the parts, cosine theta, and the 2 sine theta minus 1. We're going to set each one of those equal to 0, like this. Go ahead.
If you subtract it to that side,
Yes.
why is it being multiplied by?
No, there's already a cosine. So you got this sine and cosine, right? If I subtract cosine from this side, I get 0. And then I have the original part, what I had here, minus the cosine.
So then how would it just go to 2 sine theta? It would be the next.
It's 2 sine theta cosine theta, or those are multiplied together. I can't subtract the cosine away because it's not, they're not like terms.
So where does it go then? Yeah.
It's just right there.
No, you move it outside.
Hold on. Listen. Shh. So once you've got your trig functions like this, you solve them for 0. So cosine's done, but sine's not quite done. We get down to here, and it's at this point I have to go back to my unit circle and decide. Let me encourage you. If you do not have the unit circle memorized, you need to go ahead and start acting like I don't have the formula to look at. I don't have the sheet to look at. Next week you won't be allowed the sheet. Okay? Tomorrow you will, but not next week. Formulas, yes. Unit circle, no. So the question is, if you go back here, cosine of theta, that's the x coordinate on my unit circle. Sine of theta, that's my y coordinate. Can you tell me where on the unit circle do I have an x coordinate of 0?
Yeah. 90 degrees.
Good. Where's 1/2 equal to y? Good. Shh. Okay? And so when you get this done, your answers are going to be the angle measurements that you see here and here. Four solutions to this problem. So if you think about this, if I go back to the original problem, if I type in any one of these 4 angles into that original equation, it will be true. If I use any other angles, it's false. Questions? Next part we're going to talk about the homework we had last night. It's the ambiguous case. I'm going to look at number 20. Number 20. Shh. Okay, listen. Last night your homework assignment was 19 to 24. 19 had 1 triangle, 20 had 2 triangles, 21 was 1, 22 was 1, 23 was 2, and 24 was no triangles. So last night I asked you to tell me how many triangles there were, and if there were 2, I wanted you to solve for both, just for practice. In class, you should have found both triangles in 11 and 12. So if you haven't found all 4 triangles, or in this case 8, then you need to make sure that you do that before you turn this in tomorrow. This is due, completed by tomorrow. Okay? But you've had 3 days to do it, so it shouldn't be a big deal. Corner folks over there. Shh. All right. So I'm going to walk you through this one more time. I want you to listen. I don't want anybody talking. I want you to pay attention to the process. Shh. If you have a question, write it down, and I'll come back to it when I get finished. Okay? When I get a problem like this, and you're going to get a lot of problems like this come the quiz tomorrow as well as the test. They're not all going to be the same type of problem. But they're all going to start off like this. If I look at this one, it says, basically instructions say solve the triangle or triangles. If none exists, write none. Okay, the instructions will be almost exactly written like that. The first thing that I'm going to do is set up like I would as if there were just one triangle. I'll label what I know. You can see that over here. And then I go ahead and write out my little chart to fill it in. I'm just assuming that there's one triangle, but I may have an idea there's more than one. And I can get that by looking at the triangle. It's an angle, side, side. It's an acute angle. Shh. Therefore, I have the potential of having 0 triangles, 1 triangle, or 2 triangles. There's a real easy way to figure out if that really happens. And you can just kind of build it into your process. It takes 2 steps to check. If there's not going to be 2 triangles, you'll know that. Then you'll throw that part away and just keep going like you've done on all the rest. So this is how you do it. I label the given information first so I know that what I have. Right? So I can already tell you I've got to find angle A first, right? Since I've got these two, I'm going to have to use B and sine B. And I'm going to have to use sine A and A because I have to find that missing part first. I don't know anything about C, so I can't actually do C yet. Yes, sir? Do what now?
I think there's an easier way to solve these 2 triangles.
How?
22 short of 27 is going to swing and swings around.
Not necessarily. There is a way to check about length of triangles. If 27 is shorter than B sine A, 22 times the sine of A, or in this case sine of B, if it is shorter than that, yeah, you're right, it won't reach. But you're not doing that right now.
Yeah, no, I was thinking of a simplistic way.
Okay? Now I'm not trying to teach you how to do it that way. Okay? Because if you do it this other way, it's just part of the process, and you'll know if there's one or not. You don't have to check anything else. Now I'm just going to say, if you go through the process, listen. I set my problem up to start with, and you got this set up. Multiply by 27 on both sides. Take the sine inverse of that decimal. I didn't write the decimal down, but you'll get a decimal. You're going to get the angle to be 41.9 degrees. Remember, if you are working your problem out and you get to the angle measurement and you think you're done and your angle is like point, big decimal, you're not finished. You haven't taken the inverse of sine yet. Okay? And so, if I work this out, here's how it's going to go. Automatically, I know that I have the potential for 2 triangles. So I find angle A, which is 41.9. This is my connection to say 180 minus A to get A prime. So we do that. We can say that angle is going to be 138.1. Now here's why I check. I'm going to add 138 plus 33, because that was the original one. I'm going to see if that's less than 180. So we do that. Turns out it's 171.1. So definitely 2 triangles. Got a room left over for angle C. Let's find angle C by subtracting from 180. C prime is 8.9. I can do the same thing to find C in the original one. I add A together with B, and then I'll go ahead and I subtract that from 180 to get 105.1. So at this point, I'm almost done with both triangles. The only thing I have to do is try and find C and C prime by using the law of sines. And I'll do one of those right now. So you do 22 over sine 33 equals sine C over the sine of 105. We're going to multiply both sides by 105, sine of 105, 0.1. And that'll give me the answer that C would be 38.9 units long. I'm going to do the same thing for C prime, except down here at the bottom, instead of sine of 105, we'll use the sine of 8.9 because C prime would change. This part would stay the same because it was in both triangles. And then I'm done. And C prime is 6.2. Questions?
Yeah, you lost me. Where do you get C?
The first C, angle C,
No.
here.
Yeah.
Okay, so the first thing we did, we know that B prime is in both triangles. We found the original A right here. That was the first thing. That's the only thing I can do. We say 180 minus what we got for A to get A prime. That's the connecting point. So then I add 33 plus 138.1. I double check to make sure that when I add those together, that number is less than 180. If it is, I got two triangles. So subtract it from 180, and you're going to get C prime. I do the same thing over here. I add the original two angles that I have together, subtract them from 180 to get 105. And then I do the same process of law of sines to find the other C and C prime side lengths. And then I'm done. The formulas I'm putting on the board, I want you to look at them for a minute.
Are you going to give us a bonus one?
Yes. Okay. Is that a different formula? Is that three different ones, or is it the same formula?
It's the same.
It's exactly the same formula. I've written it three ways because you have three varieties or three versions of that formula. I'm not going to give you all three. I never will because it's only one. What you need to remember is that when you draw out your triangle, right? When you draw out your triangle in general, the angle that you're going to be working with, the angle C right here, it has to be between side lengths A and B. No matter what triangle you're trying to find the area of, the angle that you're going to be using has to be between the two given sides. Right? So, for example, if you look at the one I have here, you have side 12 and you have side 9, but I have angle C, 63. So if I write that down in just in letters, notice I have C, B, and C. In my formula, I need one of each letter. Two sides and an angle, like an A, a B, and an angle C. So this is a problem. I don't have this side. I need angle A really to do this problem quickly. So I'm going to have to use law of sines to get to angle A like we've always done in previous examples. Okay? Now, if you look at your formula sheet, your worksheet, this is not on your worksheet, but you have, look at the picture up here, 10, angle 56, and then side length 12. If I were to try to find the area of the bottom triangle down here, it would be 1/2 times 10 times 12 times the sine of 56. 1/2 side A times side B times the sine of the angle that's in between them. Look at your picture on your worksheet.
Those aren't some angles in the triangle?
This is I didn't have room to write 12 at the bottom. That's 12 down here. Okay? So side, and angle. But look at the ones in your worksheet. Every single one of them is really, really straightforward. It's the angle that you need. But listen to me carefully. I want you to write this one down. Because this one's not the right way. I'm going to have to find a better way to get that finished. So let's look through that one and see how we work that out. Basically, you're going to have to use the law of sines. And the first thing I'm going to do is find angle B. Once I get angle B, I pretty much have angle A already. So we're going to say, we're going to find angle B to start with. So we'll write sine of B over 9 equals sine of 63 divided by 12. So I'm going to multiply sine 63 times 9. Somebody do this for me. I don't have a calculator. Sine of 63 times 9 divided by 12. And then I'm going to do the inverse sine of that to get angle B. What do you get?
41.9.
41 point what? Really? Okay, so 41.9 is here at angle, actually I took this from another problem, so that makes sense, we've seen it. 41.9 is here. What's angle A? 75.1. So if we're asked to find the area of this triangle, this is how I would do it. It's 1/2 times 9 times 12 times the sine of what? No, why are we required to use 75.1? Because it's the angle that's between the two side links that I've chosen to use. If you have solved the triangle altogether, you have your pick. Pick any two sides and the angle that's between them. It won't matter which one you use.
So if we remove the 12 to like in between C and B, we have to use angle C?
Yes. Okay. Now, what's the answer to that, by the way? What is it? 51.2 units squared. So that's area. So your homework tonight is real simple. Finish that worksheet. There's 4 area problems. Some of you have already done them all, which is great. Okay? Make sure that you go back over the practice problems we did at the beginning of the class. If you need to go back and watch this video, I recorded this today. You go back and look over the problems. I recorded the video last week on Thursday. It's up from last week. You go back and watch that. Tomorrow, well, just go make sure you check those out before.